Okay, in this video I'm going to demonstrate how to carry out the Hausman test using the pH test function in R, and specifically this function is associated with the PLM package. So this package is used to carry out panel regression, and one of the things that you may wish to do is to test whether you should go with a fixed effects model or a random effects model. And so a way of making this determination is to use the Hausman test. So to carry out the test, you'll need to generate an object containing the results from a fixed effects model and one containing the results from a random effects model. And then the comparison is based on the results from those two models. So what we're going to do is we're going to go into R and call up the PLM package and also request the Grunfeld data associated with that package. And we're going to run a fixed effects model and random effects model and then carry out the test. So what I'm going to do is actually, I've already have R open, but this is open up in a text file in Notepad. And by the way, you can actually download this Notepad from underneath the video description and follow along if you want to. But so what I'm going to do is largely copy and paste from this text file into R. And so what I'll do is I'm going to copy this and go to R and paste it in. And so there you can see, first off, let me just give you a little brief review. We're using the library function here to call up the PLM package. And then what we're doing right here is calling up this Grunfeld data right here. And then right here we're using the structure function in order to look at the data. So you can see within the data frame that's called Grunfeld, we have variables such as firm, we have year, we have INV, value, and capital. So I'm not really familiar with this data set per se. I know that it's utilized in the package extensively in demonstrations, but at any rate, what we're going to be doing when we run our panel regressions, we're going to be using firm and year both as index variables. So firm is representing different firms, so it's basically a subject identifier, and year is basically a time index variable. So next up, what we're going to do is our first example. We're going to be running our basic fixed effects model and random effects model. And then what's going to happen basically when we carry out the Hausman test, which is this part of the syntax right here, we're going to find that the random effects model is preferred over the fixed effects model, given that the difference between the two models is not statistically significant. So let's go ahead and do that. So here we have a data object that is being called FE1. So it's going to contain the results from our panel regression. So we're using the PLM function associated with the package. The dependent variable in this model is this INV variable. It's basically a function of these two predictors right here, and so these are time varying predictors, value and capital. This is basically a statement, an argument indicating what the data frame is that we're working with. We have model argument equals and then side quotation marks within. So that is designating that we're carrying out a fixed effects model. Here we have index equals C, and inside the parenthesis we have our index variables firm and year. And so again, firm is our subject variable basically, and year is our time variable. So let's carry out the analysis, and also down here I'm just going to use the summary function in order to look really quickly at our output. So I'm going to copy that and I'm going to paste it in and hit enter. And so now looking at our output, you can see this is everything that we've typed in above, and you can see right here we've got our coefficients table with our estimates, standard errors, t-values, p-values. There's our r-square value right here, and we have an f statistic and test results right here. So now let's run the random effects model. So we're going to use the same specification, INV, as a function of capital and value right here. The difference is that with model, now we're setting this to random. So just notice that again, with a fixed effects model, we are using within, and with a random effects model we are laying it out as random. So everything else is exactly the same. So what we're going to do in this particular case is we're just going to go ahead and copy this and paste it in to R as well and hit enter, and now we'll use the summary function and just take a quick look at it. So there are our results. So now we have an object called FE1 that contains the fixed effects results, and we have an object that that's called RE1, and that contains the random effects results. So now what we'll do is we'll carry out the Hausman test. We'll say pH test, and then we'll type in RE1, comma, and then FE1, and then we'll enter, and so there's our test. So you can see that it's basically a chi-square test. It's not statistically significant, and so because of that, our preference is to go with the random effects model instead of the fixed effects model. So next, let's scroll down and we will look at a second example where the fixed effects model will be preferred over the random effects model. So in this case, I'm just kind of respecifying the model. We're just using value as a function of this INV variable right here. And so we still have our data equals Grunfeld. That's our, again, referencing the data frame containing our data. Model is specified as within right here. Again, we're going to stick with our index variables being firm and year. For the random effects model right here, and so our object for fixed effects, I'm just calling it FE2, and for the random effects, I'm calling it RE2. And so again, the difference between these two is just that now we're setting this as random. And so what I'll do is I'm just going to go ahead and copy both of these and paste them in. And if you want to look at the results from each model, we can just use the summary function. There's summary FE2 and summary RE2 right here. And to carry out the Hausman test, we'll just type in pH test, and then we'll say RE2, comma, and then FE2. And you can see now that the p-value is indicating a significance, which in this particular case would be an indication that the fixed effects model is preferred over the random effects model. So at any rate, again, if you want to download this particular text file, it will be underneath the video description. And there's more information on the package itself and the pH function. I've included links right here to give you more details, and then there's another couple of nice presentations on the Hausman tests that are provided at these links right here. So thank you for watching.